Hello, I am Dr. Deepthi and you are learning about linear equations. When you start learning about linear algebra, one of the most important topic that you need to start with is linear equations. So what are these linear equations? Well, the name linear is crucial here. So it's basically an equation, you can say in the variables x and y, that can be written in the form ax plus by is equal to c. We are limiting here to two variables, and a, b, c are real constants. So as you can see, there is no degree greater than 1. Now, if you try to plot a graph of such an equation, it is a straight line in the xy plane. So that gives you a hint about the name linear. Now, let us try to consider a system of two linear equations. Say x plus y is equal to 7 and 3x minus y is equal to 9. Let us try to solve these two equations. Now it's very easy. You simply need to add it up so that x plus 3x will give you 4x, plus y minus y will cancel out, and here you will get 16. So upon addition, what you get is 4x is equal to 16, which tells you that x has to be plus 4. Now, if you substitute plus 4 in the place of x, you will get y to be plus 3. So the solution of this pair of equations is x is equal to plus 4, y is equal to plus 3. So these values satisfy both the equations. Now, what is the geometric meaning of this solution? We have already seen that each of these equations is going to represent a line. So now imagine that these two lines are intersecting. And what will be the point of intersection? Precisely this point, 4, 3. That means x is equal to 4, y is equal to 3. So a solution is that point at which graph of the two equations intersect. Remember, we are right now limiting ourselves to only two variables. Hence, one can make this statement. Now, if you consider a pair of lines, there can be three possibilities. In fact, that is why there are three possibilities of solutions. In the first case, you can imagine there are two lines which are intersecting, just like the example we saw some time ago. So they will be intersecting in a unique point, and this unique point is in fact the unique solution. Now, next case could be the two lines are parallel. That means they do not intersect in any point. So this means that there is no solution. And the third case is both the lines are coincident. That means each and every point could be called as a point of intersection of both the lines, and hence this line has many solutions. So these are the three cases. Let us repeat. In the first case, the lines intersect in a unique point, giving you unique solution. In the next case, the lines are parallel, giving you no solution. And in the third case, the lines are completely coincident, giving you many solutions. Now, this was about two variables. In general, if you want to write the equation of line, it can be written in this fashion. a1x1 plus a2x2 plus dot 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 plus an(xn) is equal to b, where all the ai's, that is a1, a2, an, and b are constants. And all the xi's, that is x1, x2, xn, etc. are variables. So when you consider this specific case of two variables, this reduces to a1x1 plus a2x2 is equal to b. Similar to what we saw here. The only difference is instead of writing the variables as x1 and x2, we have called them x and y. But otherwise, the meaning is not different. So this is the situation for n variables. For example, if you have 3 variables, then try to think of a solution of 3 linear equations. Now, when you say a linear equation in 3 variables, it basically corresponds to a plane in 3-dimensional space. So solutions to a system of such equations will be points that lie on all the 3 planes. Now, there could be different cases. There could be 3 completely parallel planes. In that case, there will be no solution. There could be a case where all the 3 planes are intersecting in one line. Or there could be another case where all the 3 equations represent the same plane. There could also be a case where all the 3 planes are intersecting at a single point. So try to think about the solutions in each of these cases. Obviously, when it is intersecting at a single point, it will lead to a unique solution. When there are no points in common, there will be no solution. And when the intersection is a line or an entire plane, there would be many solutions. Now, as the number of variables increases, the geometrical interpretation of such a system becomes very complex. Each equation represents a space embedded in a large space. And solutions are points that lie on all these embedded spaces. So it becomes very difficult to imagine it geometrically. So instead, it is done or it is explained on the basis of algebraic method. We will be looking at such concepts in the upcoming sessions. Thank you.